Good morning everyone. Welcome to the next lecture. Today we will discuss about one of the important aspects of a matrix, which is to find the inverse of a matrix. We will discuss here the stepwise procedures to find the inverse of a matrix. See, the inverse of a matrix, sometimes called a reciprocal matrix. An inverse of a matrix can be found only for a square matrix, which means that the number of rows and columns are equal, and it should be a non-singular matrix. We know what actually mean by a non-singular matrix. The determinant value of given matrix is not equal to 0, then we can say that it is a non-singular matrix. So it is important to note here that not all matrices have an inverse. The square matrix is invertible or it is non-singular if and only if its determinant is non-zero. If the determinant of a matrix is 0, then the matrix is known as singular matrix and does not have an inverse of a matrix. So in many real problems, we have the system of linear equations, and the inverse of a matrix provide a efficient way to solve the system of linear equation using the operation of matrix multiplication. Thus, finding the inverse of a matrix is a fundamental tool in mathematics and its application enabling the efficient computation, problem solving and the analysis in a wide range of fields, especially in economics as well. See, in order to find the inverse of a matrix, the first step is that the matrix must be a square matrix, which means that the same number of rows and columns. The number of rows should be equal to the number of columns. Secondly, the determinant of a matrix must be non-zero. A square matrix that have an inverse is called an invertible or it is a non-singular matrix. So a matrix that does not have an inverse is generally called it is a singular matrix where the determinant value is equal to 0. But in order to find the inverse of a matrix, the determinant of a given matrix must be non-zero or it is non-singular matrix. So the formula for calculating the inverse of matrix, which is generally denoted A raised to the power -1, we can read it, it is A inverse. So the inverse of matrix can be found by using the formula, that is 1 by the determinant value of given matrix into the adjoint of a given matrix A. So the inverse is unique. By using this particular formula, we can find the inverse of a matrix, and that inverse is unique matrix that is satisfied where the given matrix A into its inverse will give you an identity matrix, or we can say that it is inverse into the original matrix will give you an identity matrix. So this relationship is actually shows that the product of matrix and its inverse is the identity matrix, and this property is the one of the unique characteristics of an inverse of a matrix. See, let us consider we have a 3 by 3 matrix, that is matrix A. We have a given matrix, that is matrix A is equal to A11, A12, A13, A21, A22, A23, A31, A32 and A33. We have a 3 by 3 matrix here. See, after having a particular matrix, the first step is to find the determinant value of given matrix. After finding the determinant value of given matrix, then the next step is to find the minors and the cofactors. In the last lecture, we are already discussed what actually mean by and how to find the minors and the cofactors. See, after finding the cofactors of each and every element of a given matrix A, we are going to find the cofactor matrix. See how we are getting the cofactor matrix? We are going to replace the each and every element of a given matrix A by using its cofactors. we will get a cofactor matrix. So here the cofactor matrix here it is C11, C12, C13, C21, C22, C23, C31, C32 and C33. See here the each and every element of a given matrix here we are replaced with its cofactors. See, after finding the cofactor matrix, the next step is to find the adjoint of a matrix. And we know how to find the adjoint of a matrix, which we are already discussed in the last lecture. The adjoint of a matrix is nothing but it is the transpose of a cofactor matrix. If you go for interchanging the rows into columns and columns into rows, then it will produce an adjoint of a matrix. See here, we know this is the cofactor matrix and we are going to interchange the rows into columns and columns into rows. Then we will get the adjoint of A, matrix A, that is equal to C transpose. That means if you go for finding the transpose of a cofactor matrix. So here we are going to write the first row of cofactor matrix, that is C11, C12, C13 in a column wise here. So it will become column number 1. The second row we are going to write in terms of second column. The third row of the cofactor matrix we are going to write in terms of third column of the adjoint matrix. So in this way we can find the adjoint of a given matrix. After finding the adjoint of a matrix, we can apply the formula for calculating the inverse of a matrix. And we know what is the formula for calculating the inverse of matrix, that is inverse of matrix is equal to 1 by the determinant value of given matrix into the adjoint of a given matrix A. So here by using this particular formula you can find the inverse of a given matrix. So it will become, see, the inverse of matrix is equal to 1 by the determinant value of A into C adjoint of A, which we are already formed here, that is C11, C21, C31, C12, C22, C32 and C13, C23 and C33. If you go for multiplying and solving accordingly, then you will get the inverse matrix. Okay. Now let us consider some numerical example so that it will be more clear. See, we have a 2 by 2 matrix, that is matrix A, which is equal to 7, 9, 6, 12. The first step is to find the determinant value of given matrix. See how to find the determinant value? See, we are going to take the product of diagonal elements and subtract the product of diagonal elements. So here it is 7 into 12 minus 9 into 6. So 7 into 12 minus 9 into 6, which is equal to 84 minus 54, which is 30. So this is the determinant value of a given matrix. See, after finding the determinant value, then the next step is to find the minors. See, what are the minors here? The minor of first element, that is 7, by crossing the first row and the first column, then it will become, it is, what is remaining here? It is 12. Similarly, M12, that is minor second, that is minor of 9, by crossing the first row and the second column, it is equal to 6. Then C21, we are crossing the first column and the second row, which is equal to 9. Then the fourth minus, that is M22, we are going to cross the second row and the second column. Then what is remaining here? It is 7. So we have the minus 12, 6, 9 and 7. After calculating the minor, we are going to calculate the cofactors. See how to find the cofactors. See, which is equal to minus 1 raised to the power 1 plus 1 into the minor. So it is minus 1 into square, which is equal to 1 into the first minor, which is equal to 12. So 1 into 12, which is equal to 12. Similarly, we can find the second cofactor, that is C12, that is minus 1 raised to the power 1 plus 2 into the second minor, which is equal to 6. So minus 1 cube, which is equal to minus 1 into 6, which is equal to minus 6. The third cofactor, that is C21, minus 1 raised to the power 2 plus 1 into the third minor, which is equal to 9. So minus 1 cube, that is equal to minus 1 into 9, which is equal to minus 9. Similarly, we can find the cofactor 4, that is C22, which is equal to minus 1 raised to the power 2 plus 2 into the fourth minor, which is equal to 7. So minus 1 raised to the power 4, which is equal to 1 into 7, which is equal to 7. So these are the various cofactors, that is 12, minus 6, minus 9 and 7. After finding the minors and cofactors, The next step is to find the cofactor matrix. How we can find a cofactor matrix? If you go for replacing the original elements in the given matrix by using its cofactor matrix or cofactor elements. So here instead of 7 we are going to write the cofactor element of 7 which is equal to 12. So we will have a 12 minus 6 minus 9 and 7. These are the cofactor matrix. So after finding the cofactor matrix, the next step is to find the adjoint of a given matrix. So how to find the adjoint of a matrix? If you go for taking the transpose of a cofactor matrix, that means if you go for changing the columns into rows and rows into columns, then you will get the adjoint. So adjoint of a matrix is equal to transpose of cofactor matrix, which is equal to 12 minus 6. First row will become now the first column. The second row, that is minus 9, 7, now become the second column here in the adjoint matrix. So we have a adjoint of A, that is 12 minus 9 minus 6 and 7. Now we can apply the formula for calculating the inverse of matrix. What is the formula? Which is equal to 1 by the determinant value of A into the adjoint A. So here what is the determinant value which we are already estimated here, which is 30, and what is adjoint? This is the adjoint matrix. So here 1 by 30 into the adjoint matrix, that is 12 minus 9 minus 6 and 7. Now if you go for dividing these elements, then it is 12 divided by 30, then minus 9 divided by 30, minus 6 divided by 30 and 7 divided by 30. And if you go for simplifying it, 12 divided by 30 we can write it is 2 by 5, minus 9 divided by 30 we can write it is minus 3 by 10, minus 6 divided by 30 we can write it is minus 1 by 5, and 7 divided by 30 we can write it is as 7 divided by 30. Now this is the inverse of matrix. Now we can verify the inverse of matrix by using its most important characteristics, that is inverse of matrix is the matrix. If you go for multiplying the original matrix with its inverse, it will produce an identity matrix. So let us look at whether it is producing an identity matrix or not. See, we have an inverse. This is the inverse of matrix. Now we are going to multiply the inverse of matrix with the original matrix. So this is the original matrix, that is 7, 9, 6, 12. You know it is how to multiply the two matrices. So here we are going to multiply the first row with the first column. So it will be 2 by 5 into 7 minus 3 by 10 into 6. This will be the first element. See here, both have a 2 by 2 matrix. It is possible to multiply 2 by 2 matrix because 2 by 2 matrix having the same order. So we can easily go for multiplication. And if you go for multiplying it, it will produce a 2 by 2 matrix also. So here the first row we are going to multiply with the first column. So it is 2 by 5 into 7 minus 3 by 10 into 6. Similarly, we are going to multiply the first row with the second column. That is 2 by 5 into 9 minus 3 by 10 into 12. Similarly, we are going to consider the second row of the inverse and the first column of the original matrix, that is minus 1 by 5 into 7 plus 7 by 30 into 6. Similarly, the second row again with the second column, so it is minus 5 divided by 5 into 9 plus 7 divided by 30 into 12. So if you go for simplifying it, then it will become, it is 14 divided by 5, that is 2 into 7, that is 14 divided by 5 minus C 3 into 6, which is 18 divided by 10, then 2 into 9, which is 18 divided by 5 minus 3 into 12, which is 36 divided by 10. Then here it is 1 into 7, which is 7 divided by 5, 6 into 7, which is 42 divided by 30, which is equal to, again, it is 1 by 5, that is 1 into 9, 9 divided by 5 plus 7 into 12, which is 84 divided by 30. If you go for taking the common denominator and accordingly if you go for solving it, then it is equal to 1001, which is nothing but it is an identity matrix. So if you go for multiplying the inverse with the original matrix, then it will produce an identity matrix. Now let us look at the A into A inverse. Here we are analyzed A inverse into A. Now we are going to multiply A into A inverse, whether it will also provide the same result or not, and accordingly it will produce an identity matrix also. So we want to find the product of original matrix with its inverse. So here the original matrix is equal to 7, 9, 6, 12, and these are the inverse. Now we are going to multiply these two terms. Of course, it is a 2 by 2 matrix, so we can directly go for multiplying these two elements. So here 7 into 2 by 5 plus 9 into 1 minus 1 by 5. Then first row with the second column, that is 7 into minus 3 by 10 plus 9 into 7 divided by 30. Similarly, we are going to take the second row and multiplying with the first row and the second row, then we will get these values accordingly. Now, if you go for multiplying these values, then it will be 7 into 2 by 5, which is equal to 14 divided by 5, 9 divided by 5, then here it is 21 divided by 10 minus, then here it is 9 into 7, which is 63 divided by 10, then here it is 6 into 2, that is 12 divided by 5, minus will be here because it is minus 1 by 5 into 12, which is 12 by 5, minus here it is 3 by 10 into 6, that is minus 18 by 10, then 12 into 7, which is 84 divided by 30. Now by taking the common denominators, so we can say that it is 14 minus 9 divided by 5 minus 63 plus 63 divided by 30, then 12 minus 12 divided by 5 minus 54 plus 84 divided by 30. Now here, if you go for subtracting here 14 minus 9, then it will be a 5 divided by 5, which will be 1. Minus 63 plus 63, it will become 0 divided by 30, it is equal to 0. Then 12 minus 12, which is equal to 0 divided by 5, which is equal to 0. Then minus 54 plus 84, which is equal to 30 divided by 30, which is equal to 1. So we can say that the result of a original matrix you are going to multiply with its inverse, it will also produce an identity matrix. So this property is satisfied, that is A into A inverse is equal to identity matrix, which is also equal to the A inverse into A. Now we are going to consider another example, that is find the inverse of for a given matrix A. That is, we have a given 3 by 3 matrix, that is matrix A is equal to 2, 4, 1, 4, 3, 7, 2, 1, 3. So we have a 3 by 3 matrix. First step is to find the determinant value of given matrix. So we can find the determinant value here by crossing the concerned row and column. See, it will become, taking the first element, that is 2, we are going to cross the first row and column, then what is remaining? It is 3 into 3 minus 7 into 1. Minus the second element, that is 4 into, then crossing the second column and the first row, that is 4 into 3 minus 2 into 7 or 7 into 2, plus the third element, that is 1 into, crossing the first row and the third column, it will be 4 into 1 minus 3 into 2. So if you go for simplifying it, then it is 2 into 3 into 3, which is 9, minus 7 into 1, which is 7, minus 4 into 3, which is equal to 12, minus 7 into 2, which is equal to 14, plus 1 into 4 into 1, which is 4, minus 3 into 6, which is minus 6. So if you go for multiply here again, see it is, if you take the difference between these two values, then it will become 2 into 9 minus 7, which is equal to 2, minus 4 into 12 minus 14, which is equal to minus 2, plus 1 into 4 minus 6, which is equal to minus 2. So if you go for multiplying this, then it is equal to 4 into 4, 8, minus 4 into minus 2, which is equal to plus 8, then 1 into minus 2, which is equal to minus 2. So here it is 4 plus 8, which is equal to 12 minus 2, which is equal to 10. So here the determinant value of a given matrix is equal to 10. See, after finding the determinant value of a given 3 by 3 matrix, the next step is to find the minors. See, minors, we know how to find out the minor. I am just showing 1 or 2 minors here. Then after that, you just go through it. See, the first minor, that is the minor of 2. See, by crossing the concerned row and column, that is first row and the first column, then what is remaining here? 3, 7, 1, 3. So 3, 7, 1, 3, taking the determinant value of this one, then it is 3 into 3 minus 7 into 1, which is equal to 9 minus 7, which is 2. Similarly, we can take the second minor, which is by crossing the second column and the first row, what is remaining here? 4, 7, 2, 1, 2, 3. So it is equal to 4 into 3 minus 7 into 2, which is equal to minus 2. Similarly, we have the third minor, that is by taking the third element and crossing the concerned row and column, that is first row and the third column, then what is remaining here? It is 4, 3, 2, 1. 4 into 1, which is equal to 4, minus 3 into 2, which is equal to minus 6. So 4 minus 6, which is equal to minus 2. So accordingly, we have to find out the remaining minors, that is M21, which is equal to 11, M22, which is equal to 4, M23, which is equal to minus 6, and M31, which is equal to 25, and M32, which is equal to 10, and M33, which is equal to minus 10. See here, we found the 9 minors because we have a 3 by 3 matrix, we have a 9 elements in the given matrix. Accordingly, for each and every element, we have a minor. So accordingly, we found the 9 minors here. So after finding the minor, what is our next step? We have to find cofactors of the each minor. So I am just written here what are the various minors, and because we want to find the cofactor by using the minor. So the next step is to find the cofactors of a given matrix. So the first cofactor, that is C11, which is equal to minus 1 into raised to the power, that is 1 plus 1 into the minor, that is equal to 2. So here minus 1, 1 plus 1, which is equal to minus 1 square into the minor 1, which is equal to 2. So minus 1 square, which is equal to 1 into 2, which is equal to 2. So similarly, we have the second cofactor, which is equal to C12, which is minus 1 raised to the power 1 plus 2 into the second minor, which is equal to minus 2. So minus 1 cube, which is equal to minus 1 into minus 2, which is equal to 2. Similarly, the cofactor 3, it is minus 1 raised to the power 1 plus 3 into the third minor, which is equal to minus 2. So it is minus 1 raised to the power 4, which is equal to 1 into minus 2, which is equal to minus 2. Similarly, we can also find the remaining cofactor, that is C21, which is equal to minus 1, 11, C22, which is equal to 4, C23, which is equal to 6, C31, which is equal to 25, C32, which is equal to minus 10, C33, which is also equal to minus 10. Now, after finding the minors and the cofactors, I am just writing the cofactors here separately. See, we are going to frame a cofactor matrix. We know what actually the cofactor matrix is. We are going to replace each and every element of a given matrix, original matrix, by using its cofactors. So these are the various cofactors. We are going to frame the cofactor matrix here. So the cofactor matrix here, it is 2, 2, minus 11, 4, 6, 25, minus 10 and minus 10. See, after finding the cofactors, what is our next step? We have to find the adjoint of a matrix. What is the adjoint of a matrix? If you go for taking the transpose of a cofactor matrix, or we are going to interchange rows into columns and columns into rows, we will get a adjoint matrix. We are going to interchange here, that is rows into columns and columns into row. So the first row, that is 2, 2, minus 2. Now it will become the first column, that is 2, 2, minus 2. Similarly, we are going to consider the second row, that is minus 11, 4, 6. It will become the second column. Okay. Now the third row, that is 25, minus 10, which will become the third column in the adjoint. So this is the adjoint of a given matrix. What is the adjoint? Which is the transpose of a cofactor matrix. That's why we are written here, it is CT, that is transpose of a cofactor matrix, which is equal to the adjoint. So accordingly, the adjoint is here, that is 2, minus 11, 25, 2, 4, minus 10, minus 2, 6 and minus 10. So after finding the adjoint of a matrix, what is our next step? It is we have to apply the formula for calculating the inverse of matrix. What is the formula for calculating the inverse of matrix? The inverse of matrix is equal to 1 by the determinant value of a given matrix into the adjoint of a A. So here, what was the determinant? See, determinant was which we were already calculated, which is 10, and then we have a adjoint matrix. So here we can multiply 1 by 10 with each and every element of a given adjoint of a matrix. Then it will become, see, 2 divided by 10, minus 11 divided by 10, 25 divided by 10, 2 divided by 10, 4 divided by 10, minus 10 divided by 10, minus 2 divided by 10, 6 divided by 10 and minus 10 divided by 10. So the denominator it will become 10. Now see here we can simplify these particular elements. See 2 divided by 10 we can write it is 1 by 5. Minus 11 divided by 10 we can write as it is 25 divided by 10 we can write it is 5 by 2. 2 by 10 again we can write it is 1 by 5. 4 by 10 we can write it is 2 by 5. Minus 10 divided by 10 which is equal to minus 1. Similarly here minus 2 divided by 10 we can write it is minus 1 divided by 5. 6 divided by 10 we can write it is 3 by 5. Then finally we have minus 10 divided by 10 which is equal to again come out with minus 1. So this is the inverse of a matrix. This is the actual values or elements in the inverse of a matrix. Now we can check the property which is the special property of the inverse of matrix, that is if you go for multiplying the original matrix A with its inverse, it will produce an identity matrix, or you can also multiply the inverse into the original matrix which will also produce an identity matrix. So here we are going to multiply the original matrix with its inverse. So we have a original matrix that is 2 4 1 4 3 7 2 1 3. This is a 3 by 3 matrix. And what was our inverse of matrix, which is already given here, 1 by 5 minus 11 by 10, 5 divided by 2, 1 by 5, 2 by 5, minus 1, minus 1 by 5, 3 by 5 and minus 1. So we have a 3 by 3 matrix. So if you go for multiplying a 3 by 3 matrix with another 3 by 3 matrix, of course these 3 by 3 matrix having the same orders, so we can say that the multiplication is possible. If you go for multiplying a 3 by 3 matrix with the another 3 by 3 matrix, it will produce a 3 by 3 matrix again. So if you go for multiply it, you know how to multiply it. See, we are going to multiply the first row with the first column, second column and the third column of the inverse. Similarly, we are going to consider the second row, then we are multiplying the second row with the first column, second column and the third column. And the third row can be multiplied with the first column, second column and third column. Accordingly, if you go for multiplying and simplify it, then it will produce an identity matrix, that is 1 0 0 0 1 0 0 0 1, which is nothing but which is an identity matrix. Similarly, if you go for multiplying the inverse into the original matrix, so this is the inverse of matrix. We have a 3 by 3 matrix. Again, the original matrix is also 3 by 3 matrix. So of course, we have the same order. The matrix multiplication is possible and it will also produce a 3 by 3 matrix. So here the first row will be multiplied with the first column, second column and the third column. Similarly, the second row will be multiplied with the first column, second column and the third column. And finally, the third row will be multiplied with the first column, second column and the third column. See, after multiply and accordingly simplify it, it will produce an identity matrix, that is 1 0 0 0 1 0 0 0 1, which is nothing but it is an identity matrix. So you can prove accordingly. So this is the inverse of matrix. I hope you are clear about the stepwise procedures to find the inverse of matrix. The first step is nothing but we have to find the determinant of a given matrix. Then after that you go for finding the minor and the cofactor and accordingly frame a cofactor matrix. After getting the cofactor matrix, you take its transpose, that is you are just going to interchange rows into the columns and columns into the rows, and you will get a adjoint of a matrix. After getting the adjoint, finally you can go for applying the formula for calculating the inverse of matrix, which is nothing but it is 1 by the determinant value of A into the adjoint A. Accordingly, you can find the inverse of matrix. One of the important use of inverse of matrix is nothing but it is to find the solution to the system of linear equation, which we will discuss in the next lecture. So we will see in the next lecture. Thank you.